Good morning, everyone. I hope you're all energized with coffee this morning and you won't be falling asleep. Because today we're going to talk about Pinterest's new mobile website. And for those of you who don't know, we recently released a brand new PWA, Progressive Web App. We built it from scratch, so it's a brand new code base, and we did it in 11 weeks only. A little bit about myself. My name is Imad Elyafi, and I'm a software engineer on Web Core Experience team at Pinterest. And before Pinterest, I was at Facebook and at Yandex as well. If you have any questions, please make a note, and I'll be happy to answer them in the end. So today's presentation consists of three major parts, and the first one is the story behind our new mobile web. I'll be talking about how we got to this point that we decided to rebuild the mobile web from scratch. The second part is about technical implementation, and I'll be sharing with you the recipes and technologies that we use, and also performance optimizations that we did for the new mobile website. And in the end, I will share with you the results, so hopefully you can use these numbers with your team or in your company to convince people to invest more into mobile web. And first of all, let's talk about our old mobile web experience. And we looked at the state of our old mobile web 3 years ago, and we realized that it's hurting our users. You can see the angry tweets on the left side, and people were unhappy. But we knew at the moment of that time that native apps were producing up to 80% higher engagement rate. So we did a very tough decision to push our users to use native apps. So whenever you would go to Google results search page and you click on a link that navigates you to Pinterest, you would immediately see this pop-up that offers you to use the native app. And in the worst case, if you don't have a native app, you would be navigated to the App Store, where after downloading and registering, you won't be able to see the pictures of cats, like in this example, that if you would search them on Google search. All right, so we knew that we were upsetting some users, but for the size of the team at that moment, we truly believed that it was the right decision to do to push people to use native apps. But now we are much bigger and we're ready for an upgrade. At Pinterest, we run experiments before we ship UI changes. We don't ship UI changes just because they look cool. And while the metrics showed us that pushing people to the native apps in overall improved the engagement metrics, we didn't measure the sentiment cost. We didn't measure when a user won't come back to our website because they had bad experience in the first place. And in reality, we can't measure what we're missing or what we are losing, because if person would have a bad experience, he or she just simply would not click on search results in the next time. So the lesson learned, be aware of the compound sentiment cost of aggressive growth strategies. So we came to a fork on our road, whether we continue to upsell the native apps or do we invest into mobile web. And thanks to one of our team members who started it as a Makeathon project and who built Pinterest feed, which was as fast and nice as the feed on the native apps, we decided that investing into mobile web worth it. Some of you may ask, what are the other reasons investing into mobile web, except for the sentiment cost? And first of all, people in many countries still pay per megabyte basis for their internet connection. Also, they may not have as fast hardware as we do have here in Russia or in California or somewhere in Western countries. So people, they just don't want to download or update the native apps. And by not having fast and reliable mobile web experience, we're missing providing good opportunity for these users. The second reason is, by not having lightweight and fast and reliable mobile website, we are losing an opportunity to convert the low-engaged users into high-engaged users. And obviously, if you have faster and more reliable experience, you will be ranked better for SEO in Google search results. And one of the mostly commonly asked questions was why we didn't create a responsive website. And about 5 years ago, there was a huge push for making responsive websites which should work perfectly across different devices and platforms, for example, on desktop and on mobile devices as well. And our answer is, if you have a team of 20 web engineers or more, you should definitely invest into mobile web. Some other reasons for the forking mobile web. And first of all, whenever you build features on desktop, you would immediately test them in Google Chrome browser. But if you want to make sure that everything works well, you have to test them on different Android devices and different mobile devices. And unlikely your engineers would do it. So it will lead to a large amount of bugs that you want to avoid. Another reason is, whenever you have a single app which combines mobile and desktop, you would have logic forks like which says if desktop or if mobile and do something for one platform or another, and it immediately leads to increased logical complexity that goes out of the control. Another reason, if you don't have a lightweight mobile website, you're losing an opportunity to test assumptions for your target audience. And these are the people with slower internet connection and much slower hardware. And in the end, responsive design works better for the websites which more like news website where you have a bunch of text and images. So it's much easier to adopt this design onto smaller touch screens. While, for example, Pinterest is an app where you can change your boards, send a message, you can repin something. So every single feature works better when it's designed for touch devices. Since we decided to build a new mobile web app, now we can think about how we approach the problem. And a year ago, when I was presenting at HolyJS about React migration, I was advocating for incremental approach when you rebuild your website piece by piece, page by page, iteratively. But with the mobile web, we decided to do the opposite. And there is a couple reasons for that. First one, we didn't invest in our mobile web that much, and it was much easier to do the code freeze. The second reason, we were building a brand new website which shares zero to literally nothing with the old one. So it was much easier for us to start it as a greenfield project. It was the story behind our mobile web, and now we're moving towards technical part. And in the heart of our new mobile website, we have progressive web app technology, which is the term that denotes a new software development methodology, which basically takes the best of web development and the native apps. It's basically that website that has taken all the right vitamins from the native apps, so it can behave and work more like a normal app downloaded from the App Store or Play Store. And on this slide, you can see some of the main features of PWA. Of course, it's the app shell, which is the minimal set of JavaScript, CSS, and HTML that is needed to render the content inside of your frame. Basically, it's a skeleton of your app. And in combination with Service Worker, you can achieve very big performance improvements, and I'll be talking more about it. Like in the native apps, you can prompt user to send him push notifications, so you can re-engage your user and improve engagement metrics. And with the app shell, you can provide meaningful offline experience, and I'll be talking more about it. Here are some of the other features of PWA. Even this list is not exhaustive, and I'll be talking more about background sync. We're already using credentials management API. You can open the native web share prompt. You can have access to camera hardware, device memory, and many others. And all of it is possible because of the service workers. And before I will start talking about implementation of our progressive web app, let me give you a very high-level overview of service workers. How many of you have used service workers before? How many of you have written a service worker before? So we have probably 50%, which is pretty good. All right, let me give you a very high-level overview. I'll go over it quickly. So a service worker is a script that stands between your browser, JS, and the network. And among many other capabilities, it gives you an ability to intercept a request or response and respond to it in different ways. And before you can start using service worker, you have to register a service worker. And normally you would do it on window onload event, and after the browser will download the service worker file, it will go to installation and activation steps. And by the way, this is the actual URL of service worker of Pinterest. You can go online and take a look if you want. So after registering service worker, we would go to installation step, and this is the right place to do some pre-caching. You would normally cache some critical assets in JavaScript during this moment. And if installation goes smoothly, you know that all these assets, they are downloaded and they are in cache, and you can go towards activation step. So in the activation event, you would normally do some sort of cleanup. So you would take care of the old caches and you would normally delete them. Since service worker is a special type of web worker, you can send a message to communicate between browser.js and service worker. And this is here where the power of the service workers comes from. As I mentioned before, service worker is a proxy between your browser.js and the network. And on this slide, you can see the cache-first strategy setup. Basically, we would try to fetch resources from the cache if they are available. Otherwise, we would hit the network. So just to recap, service worker is a proxy between browser.js and network. You have to register it. You have to go through installation and activation step before you can use it. And now let's take a look how it works with Pinterest. And for dealing with service worker API, we're using the library called Workbox. It just makes your life much easier, but you can achieve the same results if you use the native API. So let's say user opened browser tab and type in pinterest.com. So we send a request to the server, and things are happening in a normal way. We're receiving an HTML response from the server as we would normally do. And the browser will parse the HTML response, execute JavaScript, spawn additional requests for the other assets, and it will call register service worker on window onload event. Here where we go through all these installation and activation steps. So we would do aggressive pre-caching of all the critical assets. For example, in our case, it's JavaScript that is needed to render our app, and whatever normally you would put inside of the head tag. Then we would do aggressive pre-caching of the app shell. So it would help us for the future revisits, and I'll be talking more about it. And we would set up cache-first strategy. So we have two types of caching. The first one is aggressive pre-caching, when we fetch the resources before we go to activation step. And the other one is cache on the go, where we fetch resources only when they're needed, when we're navigating to a different route, but we don't pre-fetching them aggressively. And another cool thing that I want to mention, if you're using accelerated mobile pages, you can pre-install your service worker from an AMP page. So by the time when user will go to your website, everything will be already in cache, and loading times would be significantly improved. I will share the numbers. Now we can see how the caching on the fly works. It's pretty simple. Let's say we navigate to a profile page and we want additional bundle for the profile page. And our browser would send a request, and if this asset is in the cache already, then we would respond from the cache. We don't have to do any network requests. Otherwise, we would hit our CDN and retrieve the asset. So it's pretty simple. So this is how the first page load looks like. Let's take a look what happens if we go to Pinterest.com again and we do page reload. And we don't have server-side rendering for authenticated users in favor of the app shell. And there is a couple reasons for that. First of all, metrics showed it works better and faster. Then it reduces logical complexity, and it reduces the load on the servers. And during the explanation of the first page load, I briefly mentioned that we do app shell pre-caching. And the page revisits is the place where it comes into play. So we send a request to Pinterest.com as we would normally do in the browser. And we return the app shell from the cache. And the app shell is the skeleton, the minimum of HTML, CSS, and JavaScript. So pretty much whatever we would normally return from the server. So our browser normally parses this HTML, executes it, sends another request to additional JavaScript resources, and so on and so forth. But the only difference is we already have everything in cache, so we don't have to send all these requests over network. So we save a lot of time. Since PWA is an app, we can update our app, and let's see what happens when we update the version of our app. Let's say our user actively using Pinterest, he wants to save a pin, and we send an API request. So the service worker would just bypass this request because we are not caching API responses. We want to have the data fresh. And our response would contain the information regarding the pin, but it also would contain some additional metadata, which is, we call it client context, which would contain the app version, some information about experiments, or some other data that is related to the initial state of the user. So we would receive the response, and we would compare the app version. And if the app version is the same, we don't have to update it, but we're doing one cool thing over here. Do you remember I mentioned that we're aggressively pre-caching the app shell, and this app shell contains all the necessary resources to initialize the app. And in order to do so, you have to contain initial state. And because it's cached inside of the browser, we can have some changes to the initial state, and it becomes stale. So how do we keep it in sync with the server? So for that reason, we would store the updated client context inside of the local storage. Thus, by the time when user would come back to Pinterest, we would get the initial state from the app shell, and then we would override the differences with the local storage. Otherwise, we would have to do some sort of recaching of app shell, or we would have to reinstall service worker, which is pretty expensive operation, and thus we're saving some performance. Now, let's say our app version is updated, and we have to update our app. So in this case, we would call service worker update, and we would go through normal installation and activation steps. But in order to make it active right away, we have to do a couple of things. First of all, we would call skip waiting during installation. So by the time during installation, so in this case, we would go to activation step immediately. And then during the activation step, we would call client's claim in order to make it active in all browser tabs. I know this is a lot of information, but it's just cool to remember that if something happens and you update your service worker and you still, for some reason, you're seeing that the old service worker is still there, you have to do these two things in order to make it active right away. And after all of this, on the next page navigation, we would do the full page refresh in order to re-execute newly pre-cached JavaScript. How are we doing so far, so good? And before I move forward, I want to mention another cool optimization. After we started using service workers, we started generating a single service worker per each locale. And this was not only important for repetitive visits, for performance improvement, but also for the basic offline rendering, because with service workers, we were able to cache the locale bundle. I'll be showing you a video about how the offline rendering works. And another cool optimization that we got for free is because the service workers cache is actually much faster than the regular cache. Basically, we would skip some of the compilation and parsing time. And in this example, we shaved 30% or 300 milliseconds on the main bundle, and it's not speaking about the other bundles. I think this is pretty cool, and you don't have to do anything for it. So as a result of service worker caching and the app shell, we can provide meaningful offline experience. Let's take a look at this video. So we go to Pinterest.com. We click around. Everything works as expected. And now we go offline. The app's still working. So now we do full page reload. And you don't see any pins because it just gives you a platform for experimentation, and we just started an experiment where we would show to users the unseen pins from the previous load. And we're running this experiment, and hopefully soon it will be in production. But this just gives you an opportunity to test different assumptions and run different experiments. Now let's talk about bundling. And yesterday in the discussion zone number 2, we were actively talking about client optimization, and I think this may answer on some of the questions. It's not a secret that the JavaScript size is probably the most critical bottleneck for the performance. And getting a web page to load and get interactive faster benefits from loading only the code that user needs upfront. By skipping the unnecessary code, we would reduce the network and parsing and compilation times. So in order to do so, we decided to break our bundles into 3 different categories. The first one is vendor chunk, which contains all the third-party libraries, like React or Redux. The main chunk, entry chunk, is the core logic and all the necessary libs that we created Pinterest. And the rest is async chunks, which provide the code for each of the routes. And in the end, all these async chunks are pretty small. They are less than 3 kilobytes on average. We're using Webpack for bundling. It works well for our needs. And on this slide, you can see an example of route-based code splitting. This is a code snippet of the close-up page. And you can see at the very top, there is an import statement with round brackets, which means that it's a dynamic import in ES7, meaning that Webpack will treat it differently and will combine all the assets into separate bundle. So we have another chunk for this route. Also, you may notice there is a comment Webpack chunk name, which says close-up page. And if you can guess, we're using it for the caching, because before you would have to deal with all these crazy hashes with the file names, right? But now you can use regular expressions inside of the service worker, and you can pre-cache or set up cache-first strategy based on regular expressions, which is pretty cool. And on this slide, we can see how a progressively loaded code shows that there is no need in monoliths or megabyte-sized bundles. You can see at the very top, first 4 requests are the critical resources, which is entry chunk, vendor chunk, locale. And after, we can actually even track what user visited. So we started with the home page, Then we went to close-up page, explore page, and search page. So we were downloading these resources later only when we were needed with them. And in order to understand the problem, we used the tool called Webpack Bundle Analyzer. And you can see on this slide how it shows the problem before we applied some of the optimizations. We can see that our two main bundles, they're still relatively small, and meaning that async code contains a lot of repetitive and redundant code. This is what happened after we applied our optimizations. So we moved a bunch of code out of async chunks in favor of a slightly larger entry chunk. But in the end, most of our async chunks, they reduce in size by 90%, which meaning that most of them less than 3 kilobytes, and the home page is only 1 kilobyte. So we talked a lot about performance optimizations and other stuff. Now let's take a look at the loading times, what happened after we applied all of it. So this is our old mobile web experience on average Android hardware and slow 3G network. We can see that because of the huge monoliths and megabyte bundles, users always had to wait up to 23 seconds before website was getting interactive. The new mobile web is a drastic improvement. We not only shaved hundreds of kilobytes of code, but also users now have to wait only 5.6 seconds to get to interactive. And this is on average Android hardware and slow 3G network. And thanks to the app show, the repetitive visits are even better. The first pane is less than 1 second, and time to interactive is 3.9 seconds. So we talked a lot about service workers and bundling, but there are some other cool features that we have in our app, and I want to talk about background sync. And this is a very useful API that is needed if you want to send some information in the background. Basically, before we were talking about how to fetch the data in a smart way, and now we will be talking about how to send the data in the background. And this is good for situations like, let's say a user wants to save a PIN and all of a sudden there is no internet connection. So we can defer these actions and do it later. Now, let's take a look at the very high-level view of normal request lifecycle. It's pretty obvious, just want to go through it. So let's say user wants to save a PIN, we send an API request, service worker will bypass it, we're getting a response, and it goes to the browser. But let's see what happens when the request is failing. So we save another PIN, the same process repeats, and the service worker acts as a proxy. And let's say all of a sudden we have some sort of internet connection failure or a request timeout. So in this case, we do a couple of things. First of all, we serialize our request and store it inside of the IndexedDB, so we can access to it in future when the background sync event will fire. And another thing, we would register the sync event so it will actually fire later. And we send a response back to the browser, so browser even doesn't know, like browser.js, that we do something in the background. Now, once the sync event will fire, we'll retrieve the data from the IndexedDB, we'll deserialize it, and we'll send the request using Fetch API. So now we can do all these things, and we can send the data in the background. And the cool thing about it, that it can fire, this event can fire even when the browser tab is closed. So user not even using Pinterest at all, but we can still in the background sync our data. And if the status code is less than 500, then we just simply pass back the response to the browser.js. Otherwise, we would do the same thing over and over, because the response is less than 500 means that it's not worth retrying. It's not related to server-side error or something like that. So with the background sync, you can actually make sure that the data is saved, whether it's just some user changes or context logs or ads impressions or whatever you have to save. So we talked a lot about service workers, and this part is unrelated to service worker. It's about data management, and for the data management, we're using a normalized Redux store, which acts like a client-side database. So this is perfect for situations when user on the home feed clicks on a pin in the grid, and we already have some information on the client, so we can show this information to the user while we're waiting for the response to fill the gaps. By the way, the Redux dev tools are enabled in the production, so feel free to take a look if you want. Let's go over how it works. So this is an example of the API response for the pin. And let's say user saved the pin, and we're receiving this as a response. And if we take a closer look, we can see that in reality, we have the information related to the pin. We also have information related to the board where this pin is stored, and we have information about 2 other users. So we know that these are 3 different types of entities. So we decompose our response, and we stick all these entities into the right place. You can see in the Redux store we have pins, which is an object, and the keys are the keys of the entities that we store in there. So pretty much works as a normalized database, and here's how it looks like in the Redux DevTools. You can see there is information about 3 users, and first one is the active user, the one that is using Pinterest right now. The other 2 were received in the API response, and we have some information about the pin, about the board. So it's the single source of truth, very memory efficient, super easy to debug, highly recommend. You can go online and take a look if you want. The Redux DevTools are enabled in the production. So we talked a lot about our major optimizations, but there is a lot more that makes our mobile website so cool and user-friendly. I want to go very quickly over all these little cool features. And one of the cool features is optimistic UI updates. So users, they don't have to wait until the response comes back. We update our UI optimistically, so things like the nav bar have immediate response and fill. Another cool thing is we created tab area component, which handles all the touch interactions with the app by providing that native feel from the native apps and maintaining first-class accessibility. While using Pinterest, you can notice there is a little circle when you click on the nav bar, which means that the user actually doing something, gives you information about it. There is also an optional compressed item state that we're using for components like pin or something like that. And of course, there is pull to refresh animation, which makes it look and feel like it's a native app. In the core of Pinterest, we have Pinterest Grid, and because of that, we created a highly optimized masonry grid component, which has inbuilt virtualization and mounts only images that are inside of the viewport. And also, it would lazy load all the future images, so you would have a truly infinite experience when scrolling. Another little cool feature that I really like is improving perceived performance, and it's used for when you have like slower internet connections, and while users are waiting for the images to be downloaded, we would show the dominant color as a placeholder. Was it slow enough? And we really saw that our app is much better and faster. But let's take a look at the results. And before I will share the numbers, instead of many words, let me show you this video. This is comparison of the old website and the new one. So the old one is still loading while we're already using the new one. You can see how much we can do for the 17 seconds that we were waiting for the old website. And here are the numbers. They speak for themselves. The engagement metrics were up by 40, 50, and 60%. I call this is the impressive impressions graph. You can see how you can see this pivot point that represents the time when we ship the mobile version for authenticated users. And American culture of using native apps is not common everywhere. And if you have only one chance, what you would give to these users? And important note that we haven't completely shipped the mobile web because at the time when I was putting these numbers, we were still working on unauthenticated users for people that are not logged in the browser. So these metrics will continue to go up. And also, we've seen very little to nothing cannibalization from the native apps. Basically, we were not stealing engagement from the native apps. We were producing new engagement. And when we were building the mobile web, it was a huge struggle to make people understand that there is no need to push people to the native apps. But they were saying, but we know that the native apps perform better. No, you know that the native apps perform better than the old decrypted version. Thank you, and now I can answer your questions.
Thank you, Imad. You can ask your questions. If you don't know English very well, we can translate it, of course. Help you? Okay, давай.
Hello, first of all, thank you for sharing your experience. I actually have a question. Have you experimented with server-side rendering?
Yeah, so during my talk previous year, the question was, have we experimented with the server-side rendering? And this mobile web experience is continuation of the last year project when we migrated Pinterest to React and we enabled server-side rendering. So by default, it was server-side rendering. But apparently, the metrics and experiments showed that for authenticated users, it's actually better to turn it off. And for unauth users and for bots, you obviously have to enable it. Yeah. I hope this answers your question.
I have a question. What framework you used before React?
So for mobile web, we were already on React, but before React, we were using in-house built framework called Denzel, which was similar to many other frameworks that were introduced like 5-7 years ago, which using like object-oriented programming and things like that.
Hello. I have a question actually not connected to PVA, but in your news website, there is a menu located on the bottom of the page, yes? But in mobile Safari, when you tap there, you get a Safari bar, actually. You understand what I mean?
No.
If you tap at the bottom of the page in mobile iOS, you get a menu from Safari with navigation. So how you handle it? If I tap at the bottom of the page, I won't get interactive with the site. First, I will get Safari menu.
Oh, I hear what you're saying. So, yeah, we had this problem, and actually, I don't remember how we fixed it. Like, yeah. So, I can take a look at the code later because there was like a lot of things like that. If you want, just contact me, and I'll share it with you. There is a bunch of things like that. Like, so I don't remember how all of them work. Like these little UI changes.
Hi there. Thank you for your presentation. I'm interested. You mentioned you migrated to React, and this whole project was a greenfield project. Is this was intentional from a React Native way? To reuse the code after migrate? I mean, use a PVA and also make the same experience with the same code in React Native later, or this wasn't in the plan?
So the question was it intentional to migrate to React and then to use React Native code for the native apps and so on and so forth? So the intention wasn't like that, even though we're already experimenting with React Native on Android and iOS apps. The thing is, the mobile web is actually targeted to different audience, to different users. Native apps are like for much faster hardware and so on and so forth. That's what I mentioned in the talk. But the mobile web is more lightweight experience, so it will live its own life. Now we have 4 platforms, and it will be optimized for this user. So even UI may look differently. I hope this answers your question.
Thank you very much.
Thank you for presentation. As I understand, nowadays you have both native mobile application and PWA, and the user can place PWA icon to the screen, and in terms of user, it will look as a native application. Doesn't it confusing the user if the user have 2 Pinterest icons on the screen, and especially if there are some difference in terms of user interface in native application and PWA application?
So if I correctly understood, the question is there a confusion between PWA icon for the mobile app?
Yes, and the user can have both.
Yeah. So the thing is, if you remember from the metrics, we didn't have any cannibalization from the native apps. Basically, users who were high-engaging users on the mobile web, they were staying with the mobile web or with whatever platform they were using. It's like our metrics didn't show there is something wrong with it, but unless a user is actually using 2 platforms, which normally is not the case. So there might be confusion, but in general way, it works fine.
Okay, we will deliver Imad to discussions on number 1 in 5 minutes. Yeah, actually, we will just...
Yeah, bring a truck.
Yeah. Okay, thank you, Imad.
Thank you.